So today we shall discuss the transaction processing. This is in fifth module. So this term transaction, we might have heard um, everywhere on a digital world. Whether we are transferring uh, amount from one account to another account or to other person's account, or we are when buying anything, putting the products in our shopping cart or buying a stock in a share market. So everything is a transaction. So a transaction is nothing but an execution of a process that includes one or more database access operations. So when we are transferring money or amount from uh, one person to another person, then so the database interaction that happens is, first, if I want to send say 1,000 rupees to someone, the first database interaction that happens will be to verify whether I have a balance of 1,000 or not. So if I'm having a balance of 1,000, then the amount will be first debited or decrease. Debit means decreasing. So that amount will be debited from my account, and once it is debited successfully, which means in my account balance gets reduced by 1,000. Then after successfully debiting my account, the other person's account will be credited, which means their balance gets increased by 1,000. So all these entries will be made in the database log and a transaction ID is generated. So transaction ID will is a row in a transaction table where it will have from which account to which account the amount is transferred and what is the amount value, date and time, everything will be stored. So that transaction ID is displayed to user for future references. So that is these series of database operations, that is uh, reading the balance from my account, that is a database retrieval, and writing or update operation on my account and update operation on the other person's account. So these three database interactions put together, it is called as a transaction. It is a logical unit of database processing. So the three database operation together is called as a transaction. So each execution of a program is a distinct transaction with different parameters. Be it the bank transfer program parameters will have an account number, checking the account number whether the account number itself is valid or not, and then transferring the amount. So these things is called as transaction. So a transaction is a set of operation which will maybe we can define as a standalone, specified in a high level language like SQL, and it is submitted interactively, and it contains database operations embedded within a program. So the transactions can be executed individually or within a program. So there will be transaction boundaries. So boundaries indicate the beginning and ending of a transaction. So a transaction is said to be successful if all the operations execute perfectly. So if any one of them fails, for example, we have encountered many scenarios where amount is debited from one account, but it is not credited to the other accounts. So these scenarios will also occur when transaction fails. So when transaction fails in database, the database operations that are performed should be rolled back, which means the amount that is debited from my account should be sent back. So that operation is also important in any transaction when a transaction fails. So a transaction is said to be failed if all the if any of the database operation that is specified in a transaction fails. So if it fails, then all other operations that are performed previous to that should be rolled back. So that is why in online transaction it takes maybe around 2 to 3 working days to return the amount. So because they will again run the script to check which are the failed transactions, and within the failed transaction they will again verify whether the amount is debited or not. So if the amount is debited, that particular transaction will be reversed. So an application program may contain several transactions. So each transaction will be, you know, demarcated with beginning and ending boundaries. So in order to process the transaction, so we have transaction processing systems. So these are the large multi-user database systems which supports uh, thousands of concurrent transactions per minute. So if you take any banking applications or even the Google Pay, so at a given point of time there may be millions of transactions occurring. So the transaction processing system must be capable of providing the concurrency. Concurrency means multiple users performing the transaction at the same time. So we have two modes of concurrency. So when we talk about concurrency means the process executing at the same time. So interleaved processing and parallel processing. So in interleaved processing, the concurrent execution of a process is interleaved on a single CPU. So which means there will be a single core in the CPU, and each transaction will be interleaved, means the first transaction will execute after certain time the second transaction. So there will be a cycle, maybe in the round robin fashion the transactions are executed. In parallel processing, the processes are concurrently executed on a multiple CPUs. So when we have multiple cores in the CPU, so each transaction will be spawned as a separate thread, and each of these thread gets executed on a separate core of CPU, and thus achieving the true parallel processing. So the basic transaction processing theory assumes interleaved concurrency. So earlier, uh, the transaction processing used to happen in interleaved manner. Nowadays, with the advanced technologies in CPU, and many cores are available till octa core, and even some applications and our server systems can have multiple processors. So these transactions can execute at a same time. So this is an example of a interleaved processing versus parallel processing of a concurrent transaction. So these are the time intervals T1, T2 and T3, T4. So A is executing. So at this time, then B gets executed, then B gets stopped, A gets executed, then B gets executed, and both the transaction will get complete A and B at time T2. So if you observe the time interval between T1 and T2, none of A and B are getting executed at the same point of time. It is just the interleaving. So one process is executing, it is stopped or swapped in. So you might have learned this term in your operating system, that is a process swapping. So one process gets stopped, it will go to paused state, then from there it will go to ready state where another process is brought in for execution. So likewise, so the two transactions A and B gets executed between these two intervals, and it is interleaved processing. Whereas on the other end, in a parallel processing from time T3 to T4, If you observe, both the process C and D are getting executed at the same time but on a different machine, that is CPU 1 and CPU 2. So this is just a grand chart representation of these things. So for a transaction processing purpose, a simple database model is used. So again, database is a collection of named data items. So here the size of a data item, it is called as granularity. So lesser the size of a data item, it is better for the transaction, because in transaction series of steps has to be carried out. So if each step is small in size, then the successful execution, the probability of successful execution of that a granule is higher. So here the granularity is defined for a database field, maybe for an attribute or an entire tuple or the whole disk block itself. So transaction concepts are independent of granularity. So the basic operations that are performed in any transaction on an item X. So this item X, it may be a attribute, it may be a tuple, or it may be a block of data. So the basic operations that are performed is reading and writing. So it is mentioned as read underscore item of X, where it reads a database item named X into a program variable. So a database value is read and stored in a program. Write item, so this indicates writes a value of a program variable X into the database item. So reading from the database and storing in the program variable is read item, and in write item the program variable is written into the database. So read and write operation is a basic unit of data transfer. So if we consider the data as a block of data, then it is the transfer from a disk to a computer main memory. If you are reading from a hard disk, then read operation means from the hard disk the data is read and stored in the computer's main memory, that is RAM. So that is one disk block. So a data item X will usually be a field of some record in the database, although it may be a larger unit such as a whole record or even a whole block of data. So read item command includes the following steps. So again, read item can be subdivided into certain steps. So if we are reading it from a disk, then the first thing that is done is to find the address of a disk block that contains this particular object, that is X. Then once the block is identified, then copy that disk block into a buffer in the main memory. So if the disk block is not already present in a main memory, we will bring it. So then we will copy this particular data item from buffer into a program variable named X. So these are the steps that actually takes place when we are reading a database item X. So on the other side, when we have a write operation, so the write command will also contain certain steps. So first, the address of the disk block that contains item X will be found. Then copy the disk block into the buffer in the main memory. Then copy the item X from program variable into the correct location in the buffer. Then store the updated block from the buffer back to the disk. So it doesn't directly write into a block. First, we will get the block into the main memory, buffer of the main memory. Then we will write the variable into the buffer memory and then put the entire block which is there in the buffer memory back to the disk. So these are the four steps that happens in a write up command. So the notation for transaction, so all these things which we uh, operation which we discussed will be represented in a notation. So this notation focuses on the read and write operations. So on a shorthand notations for uh, this transaction will be T1. So T1 indicates it is a transaction number 1, that is the transaction name, followed by a colon. So B1, R1 of X, W1 of X, R1 of Y, W1 of Y, E1. So that is B1 and E1. It specifies the boundaries of a transaction, that is begin and end. So B1 indicates beginning of this particular transaction. R1 means read one X, write one, that is X, then write one Y, write one Y, then end. So here R indicates read, W indicates write. So 1 indicates the unique transaction identifier. So here the transaction ID that we call. And similarly the second transaction, it is represented using T2, beginning of second transaction, that is B2, reading 2 of transaction Y, writing second transaction Y, and ending. So this is the notation in order to describe the transaction operations. So two simple transactions are mentioned over here. So the same, the transaction 1 and transaction 2. So in the transaction 1, we are reading a value X. So it is stored in a program variable. Then from this particular X, we are subtracting a value, that is N. Then we are writing X. So the updated value is written back to the database. Then read the item Y. Then from Y, it is incremented by N and written into back to the disk. So this is a typical data amount transfer from one bank account to another bank account. So X, we can take it as one bank from account from which the amount is debited, and Y is the another one where the amount is credited. So decrease from that account on one side, and after that we increase the amount in the another account and write it back. So these are the read and write operations that can be done in a data amount transfer. On the other side, T2 another transaction where we are just increasing, reading it, increasing it by M and write it back. So this can be a person depositing amount in his own account. So in that case, there will be no debiting, only crediting happens. Only one account is involved in the transaction. So that particular transaction can be divided into these many steps. So when we have a transaction, then there comes the concept of concurrency control. So concurrency control is required when we have a multiple transactions happening at a same time. Before that, we shall see what are the problems that occurs due to concurrent transaction. So that is the last update problem. So last update problem occurs when two transactions update the same data item, but both read the same original value before the update. So this, in order to understand this, so let us consider, so two persons A and B are sending the amount to a third person C at the same time. So what happens when the transaction of a person A is being carried out? As the first step, the balance of the person C should be read, because in order to increment it. So similarly, when the transaction of person B is carried out, then also the balance of person C is read. So both this transaction happening at the same time, they may read the balance at the same time. So when the same value is read and it is incremented and it is written back. So while performing these operations, one of the update can be lost, because the one that happens at the end will be the one that is stored in the database. So that is that problem we call it as lost update problem. So same time both the transaction will read the value, both of them are sending the money, so both will increase the balance and it will write back. So when it does this, one of the transaction will be lost. So this problem is called as concurrency problem. Another one is the temporary update problem. So this is also called as a dirty read problem. So this occurs when one transaction update the database item X, which is accessed by another transaction T2. Then what happens? T1 fails for some reason, but X was read by T2 before its value is changed back after T1 fails. So rollback and undone is done, but still T2 has already read the value. So when the transaction fails, so then also we'll have a problem of temporary update. So this is a example. The first one indicate the last update problem. So here read X, then decrement the value, write the value X. So this is a typical uh, decrementing or debiting an account. On the other side, what happens? Read Y, increment the balance, then write Y. This is one transaction. When this T1 is happening, at the same time, another transaction may be accessed. So what it does, read X, X is incremented and write X. So in this transaction, it is decreasing the amount. In this transaction, it is increasing the same amount, same variable X. But when this particular read operation is occurring, it will read the old value of X, because the X value, if you observe the time series, X is updated here. But before updation only, T2 is reading the value. So T2 reads the value, then it increments the value, then T1 updates the X, then after that T2 updates the X. So if you observe the timeline events, so this will lead to inconsistency. So that is, this X has an incorrect value because its update by T1 is lost. So because it is overwritten. So update by T1 is lost over here. So this is a lost problem. Then on the other side, in the second case where it is an incorrect update operation, so two transaction T1 and T2, reading the value X, X is decremented by N, then X is written. On the other side, read the X, X is incremented, then write X. After this, it is reading the value Y. So now what happens? For some reasons, the T1 transaction fails. So when T1 fails, we must change the value of X back to its old value, which means that particular transaction T1 has to be rolled back. But in order to roll back, we have to first undo the operation that we performed over here. X minus N should be reversed, which means X should be now incremented by N. But before doing this, the transaction T2 has already completed, where it is reading the updated value of X and incremented it, and it has also written back. So there is no scope for transaction 1 to roll it back, because the another transaction has already updated the value. So this is another problem that occurs in a transaction while we provide the concurrency. So these problems are occurring because of concurrency. Concurrency means two transactions uh, getting executed at a same time. So inconsistent update operations and the lost update operation. So these are the two problems. So the incorrect concurrency control. So if we summarize that particular problem, so it is one transaction is calculating an aggregate summary function on number of records, while the other transactions are updating some of the records that are involved in another transaction. So transferring a large amount between two accounts. So some aggregate function is reading the values before they are getting updated and others after they are getting updated. So you can summarize these two problems as when two transactions are processing the same records. So one is updating before the other one is calculating. So like that. So in these scenarios, so we will have a concurrency problem. So due to these problems, we need a control mechanism. So that control mechanism we call it as concurrency control. Okay. So how to provide concurrency control? So we shall discuss. So T3 reads the value x after n is subtracted and reads y before n is added, and a wrong summary of a result is obtained in this particular transaction. So consider T1 and T3 over here. So T1 is reading x, subtracting, then writing back. Then read y, increment by n, and write it. So whereas the another end transaction T3, it is performing the sum operation. So read a, perform the sum, then read x, uh, increment it by x, increment it by y also. So here it is performing, it is adding all. So which means it is aggregating all the values. So here it is aggregating, whereas the y value it is getting updated over here. So but x is already updated. So it has read the updated value of x, but it has not read the updated value of y. So this is also another example of a wrong summary result. So it need not be always the uh, debiting from one account and the crediting to another account that may go wrong. These aggregate functions also goes wrong because so the variables under consideration in these transaction will be in used by another transaction for operations. So this is another scenario where concurrency problem occurs. So another problem we have, that is unrepeatable read operation. Okay. So a transaction T1 may read an item, okay, later T1 may read the same item again and get a different value because another transaction T2 has updated the item between these two read operations. So consider the example of reservation or movie ticket or flight ticket reservation. So you are opening and want to reserve a particular ticket. So when you read the value, you will get a certain set of seats available for you, and you will try to select one seat and book it. In the meantime, you select and book. Assume the other person has selected that particular seat and already completed the transaction. Then your seat transaction gets failed. So this kind of problem, it is called as unrepeatable read operation. So where one transaction will read the value, if once again it reads, it will get a different value because some other transaction has already updated it. So this problem is called as unrepeatable read problem, where we cannot repeat the read operation. If we repeat the read operation, we are getting different values, and these different values are inconsistent. So when a transaction fails, we need the mechanism of recovery. So, so we shall stop here for today's class. So we shall look into the recovery process, why it is required in our next class. So you can put your attendance in the chat and exit.